Okay. So here is another example. Right now we have seen two examples. One is that first number to the next number guessing. The second is the height versus weight. Now we will talk about an actual important real world example which also has the same flavor but slightly different input output. But it's a very pertinent problem that AI machine learning solves in today's world. The problem is the following. Now, given the loan history of customers, predict if a new customer will pay back the loan or not. So, think of yourself as a bank manager and then you are trying to predict a new customer walks in and you as a manager have to decide whether this new customer has to be given a loan or not, right? So, you have the decision to make. Now, what do you have as input to make this decision? Well, you have a lot of historical data. You have a lot of customers, you know a lot about customers and whether they paid back their loan or not. And you somehow want to use this historical data to develop a model that relates the input to the output. The input being that new customer who walked in, the output is the loan decision, which is just an yes or no decision. Should I give the loan or should I not give the loan? Well, in other words, if I give the loan, will this person pay the loan back or not? If the person won't pay the loan back, then I should not be giving the loan to that person, right? So just to give some more details, the setup is the following. A new customer walks in, let's call this customer Hari, and you have past customer history, and now you want to use Hari's information and past customer's history to make a decision for Hari, right? So you want to learn patterns from the past customer history to decide if Hari should be granted a loan or not. This is the broader question we are asking. Now, what is the input output that I have, right? So the input earlier, the height weight example that we saw, the input was the height, the output was the weight. The input was a single number, the output was a single real number. Here it's slightly more advanced. The input is not a single number but a bunch of numbers, right? So let's say you have a previous old customer John, and now you don't have a single number to represent John, but you have a bunch of numbers, right? So you have John's age, gender, education, salary, marital status, location, right? So these are all inputs about John. It's not a single number, but it's a bunch of numbers, and so we will sometimes call these features. You have a bunch of features for John, and now using these features, you already know, right? So these are the features of John, and you already know whether John paid the loan back or not. Let's say in this case, John paid the loan back. So the output is yes. The input is the set of attributes or features or inputs about John, age, gender, salary, marital status, all relevant features, whatever you think are relevant features that you have as information, and as the output is the label, sometimes called as the label, is an yes or no answer, yes or no, 0 or 1. Now Mary is another customer, past customer with a different age, gender, education, etc., etc., and in this case Mary also paid the loan back. Smith is another customer, well, who did not pay the loan back, so the label will be no for Smith. Well, you will have hundreds and hundreds, thousands of such previous customers in your bank, and that's the data that you have. You have features and you have labels. You have customer information and you have output whether they actually paid the loan back or not. This the bank manager has. This is what I mean by past customer history here. And now for the new customer, what do I have? Well, if a new customer walks in, I can ask that person's age, gender, education, salary, marital status, location. I get features for that new customer, Hari, right? So I have all the features of the new customer. What I don't have is the label, which is what I want to predict. If this customer, Hari, is given a loan, whether Hari will pay it back or not. Well, I again have to do the OHLG thing, right? So I have observed some past customer history. Now I have to make a hypothesis that relates my input to the output. What is the way that I can relate this bunch of features to output? That's something that I have to think about. And once I do that, then I have to find the best way to relate input to output from the data. I have to learn that from the data. and then I can ask the question using the learned way to map input to output whether Hari gets the loan or not, right. So, how exactly can we hypothesize mapping input to output? We will see that in the next talk or the next lecture. Right now, I just want to show that this is a much more real world example where exactly the same idea works. You have to observe data, you have to hypothesize something, you have to learn from the hypothesis, and you have to generalize. It's the same idea that will come again and again, just that what you observe might have different, might be slightly different. It may not be a single number, it might be a bunch of numbers, features. What you hypothesize might be different for different setups. What you learn and how you learn might be different, and once you have learned, you can generalize easily. So, how exactly we can create a hypothesis for this particular problem, we will talk about it next time, but I would ask you to start thinking about this. If you had to do this, how would you do this, right? So, in other words, for this particular example, I want all of you to think about whether you will grant, if you are a manager, whether you will grant Hari a loan or not if you just had 3 customers in your bank previously. John, Mary, Smith, those are the only data points that you have, and now you have to decide for Hari. Will Hari get the loan or not, right? So, what is your decision and how are you making it, right? So, give it some thought, and we will have a discussion about this also in the live session with the instructors, and I will give you some ideas as to how this problem is solved in later sessions. Okay. More examples, we have many more examples where I won't really go into the details of all of these, maybe I will pick one or two. Maybe spam versus non-spam is another example where data science and machine learning AI is used, where you have a bunch of emails and then you want to figure out if a given email is a spam email or not a spam email. I am sure all of you have use emails. And if you use, let's say, Gmail, you will have or any email provider for that matter, you will have a spam inbox, right? So, spam folder in your inbox, and the spam folder you don't populate it typically. Typically, when an email comes, there is a filtering that automatically happens, and that puts some emails into the spam folder and some emails in the inbox, right? So, regular inbox. So, which means that this is also a prediction, a decision I need to make by looking at a lot of data, right. So, some spam classifier is sitting inside your Gmail, which looks at every email and figures out whether this email should go into the spam folder or your inbox, right. So, again, that spam classifier that is sitting inside Gmail does the OHLG, right. So, it has observed a lot of spam emails, a lot of non-spam emails, and it has figured out some way to map a given email to spam or not spam. How exactly, we will talk about it, at least we will touch upon it later. Maybe one more example is digit recognition. Well, let us say if I write the digit like this, right. So, now automatically you recognize this is a 4, right. So, if I write a digit like this, automatically you recognize it is an 8. Your human brain recognizes it, though if I ask you to write a 4 and a 8, it's highly unlikely that you are going to write it exactly this way, right. So, because there are small variations in the way you write a 4, I write a 4, you write a 8 and I write a 8, yet both of us understand the 4s and 8s that each of us write. Now, how can we make a computer recognize digits from handwriting, right. So, that's a interesting problem to solve, which is also a machine learning problem to solve, right. So, and there are so many other things, forecasting rainfall, recommending movies, right. So, friend suggestions in your social media like Instagram, Facebook, whatever that you are using, Snapchat, I don't know, all these will have a lot of friend suggestions automatically, I am hoping, and that is also, right. So, based on what kind of things friends you have already, what kind of pages you like, communities you are part of, you might get some friend suggestions, right. So, anything that works on data to make some predictions is a machine learning AI problem. Grouping pictures in phones, of course, some of the phones have this capability these days. I am sure iPhones have it. I am sure there are some Samsung phones that have seen this as well, where you can take pictures and then you automatically, the pictures are grouped based on faces, right. So, and then it will ask, well, the same person appears in all these photos. can you give a name to this person, right? So, and then once you give a name, it will create a folder with your name. Let's say Hari is the name, and then it will create a folder with the name Hari, and then all pictures of Hari will be in that folder, right? So, that is another thing where you are looking at data and trying to find patterns which are similar and so on and so forth. And there are several other examples. We have spoken about a lot of examples earlier.